Good afternoon, everybody. Rob Skingsley here from Ciena, together with Spirent and Huawei, are doing a demonstration of Flex Ethernet today, where we'll cover off a number of different topics. First off, we'll be covering off FlexE Bonding, where we're essentially pairing 100 gig Ethernet interfaces between each of our devices. That is then being channelized in a number of different ways. We'll have 4 20 gig chunks or slices, and we will have one 100 gig slice, and then we'll later on do some dynamic bandwidth adjustments on the big 100 gig slice. What the topology looks like is as follows. We have the Spirent N4U on the left. It has 2 by 100 gig FlexE ports bonded together into the Huawei. Between Huawei and Ciena, we have another pair of 100 gig FlexE ports bonded together to give us a total of 200 gig. And the same on the right-hand side between Ciena and Spirent, another pair of 100 gig interfaces bonded together. The way we have set these up is we have a number of FlexE tunnels between the devices. We have tunnels 1, 2, 3, and 4, which are 20 gigs each. And the 5th tunnel, we have 100 gig capacity on there at the moment. And at a later stage in the demo, we will expand it up to 120 gig. The reason for running it at 100 gig at the moment is so you can see that even when this link is congested with 120 gig of traffic, the 4 20 gig tunnels are not going to be impacted by the congestion on the 5th tunnel. I'll hand this over to Spirent, and they will show you how their N4U is set up for this test, and then we will repeat those steps between Huawei and Ciena as well.
This first port or Spirent is connected to the Huawei, and we have the 2 PHYs bonded into a group. And then we create a channel, have the 200 gigabit batteries. And this is our slot. The second part is connecting to the Ciena. And as well, we have the 2 PHYs bonded into a group. This kind also have the 200 gigabit batteries.
So this is the Huawei device X8, and on the Huawei device we can see we have 2 ports, 800 and 801 is connected to the Spirent. So under this port we use the all time slot for the 1 channel. So that means the 200 gigabits under the 1 channel. And then this is 2 port 802 and 803 is connected to the Ciena. So for this 2 port, we configure the total is 5 tunnels. You can see for each tunnel, we use the 20 gigabits bandwidth here. That means 4 times slot. And the last one, that means tunnel 5, we use the 4 times slot from the physical port 802, and we using another 16 times slot from the physical port 803. That means total 20 times slot is 100 gigabits for the tunnel 5. So the next, we can check the tunnel information. So this is tunnel connected to the Spirent. We can see the port bandwidth is 200 giga. And this is tunnel 1 between the Huawei and the Ciena. The first tunnel is 20 giga of bandwidth. And the second one is 20 also, third one 20, and the fourth one 20. And the 5th one, we can see the 5th one is a difference because we use the 100 giga with bandwidth here.
Thanks, Chen. From the Ciena perspective, we are set up pretty much identically. We have 4 100 gig FlexE ports. The first pair connected to Huawei, and the second pair, 35 and 36, are connected to the Spirent. Once we have those ports configured for FlexE, we then build a FlexE group. And here you can see the group ID, slot granularity, the type of PHY we have, which is our primary calendar, and some basic debugging information on that. We can also see the time slots which are configured. So we can see here on channel 601, we have 4 time slots, providing us 20 gig for the first FlexE tunnel. The same again for 602, and that continues on. And on the second, on the last one, we have 20 slots assigned. And these are split over 2 different PHYs. The first 4 on PHY 82 and the second 16 on PHY 83, and that forms our 100 gig channel. We can see very quickly here that we have the different channels configured: 20, 100 on channel 605, and 200 across to the Spirent, to show you the different options that you can configure with FlexE. For one other piece of information here, we have running on top of all of our links, we have IP interfaces. We're running ISIS across there. We have some adjacencies across the network to the different devices. And with that, what I will do is I'll hand back to Weimin, and she will show you the traffic stats that are running across the network, and then we will do some more work on the ports there.
We have the total 10 streams. They are bidirectional from the Spirent to Huawei to Ciena, then back to Spirent. From these 2 columns, the TX hour rate are listed here, and RX hour rate. So far, all the streams are running successfully.
Whilst we're on that screen, with the congestion there that you see on the left there, the 120 gig, it was congesting the tunnel 5 only. It was not congesting the other tunnels. So the other guys had 20 gigs traffic coming in. It was going out without being impacted because they're physical separation for the bandwidth there.
On my side, as you see, for the tunnel 5, we have 100 gigabits of bandwidth currently. So I will increase to 20 gigabits for this tunnel. So now the bandwidth is increased to 120 gigabits.
Now, if I increase the channels on the Ciena side, previously we had a bandwidth of 100, as you can see there. And now when we repeat look at the channels command again, we can then see that it has now increased up to 120 gig, and we have not impacted any of the other channels. And if you look at the slot map now between Ciena and Huawei, you can see that these 4, which were previously not in use, have now been assigned to channel 605. With that, I'll hand back to Spirent, and they will show you the traffic running nice and clean again.
You can see these 2 columns, these 2 streams, 120 gigabit traffic can be received.
The next, I will reduce the bandwidth from 120 to 100. And let's see, the bandwidth changed. Okay, on the Huawei side, currently we can see the tunnel 5, we use the total is 24 times slot, means 120 gigabits bandwidth. And then we will change it back to the 100 gigabits. Let's check it again. We can see last 4 times slot is free. And the bandwidth of the tunnel is going back to the 100 giga here.
Thanks, Chen. So again, we do the same on the Ciena side. We will remove the last 4 time slots. Drop those off. We can then check the slot assignments on that group, and we again see that the 4 have now been freed up again. We then look at the channel, and we will see that the bandwidth has also dropped down to 100 gig. These slots can be added to any of the channels in the FlexE group, right? So we can move them around. We can move the bandwidth up and down to channel 601, 602, 603, doesn't really matter. And with that, I'll hand it back to our friends in Spirent there, and they will show you that the traffic is now discarding again on channel 605 or tunnel 5, and you will see that the other tunnels are not impacted.
Yeah, okay. After bandwidth is discrete from 120 gigabit to 100 gigabit, only 100 gigabit is received.
And with that, that really concludes this demo. As you can see, FlexE is very, very powerful. You can run IP on top of it. You can run segment routing on top of that again. You can dynamically slice your network as you need it. And you can orchestrate this with SDN controllers to do this on the fly. When you need additional bandwidth, you can move it around as required. Thanks for joining us this afternoon, and we'll talk to you again soon.